Hello, good day. Today I'm going to discuss and give an example on how to find the roots by using a false position method or regular falsi method. So now we're going to discuss about the derivation of the false position method or the regular falsi method. Now this method is somewhat similar to bisection method, where the only difference is on finding or getting the new x, in which in bisection method, we have here the given two limits or the two initial guesses, where the only or the where the way of getting the new x is through getting the midpoint of the two initial guesses. So while on the regular falsi method, we have here a certain curve in which we're going to uh, connect those point of a certain curve into a straight line, where this is the x of u or the upper, or and then the x of l or the lower. So we're going to make a straight line out of this curve, and then that straight line that meets the zero line or the x-axis here, the x-axis will be our new x, we're going to call x of r. And then we're going to make a broken line to the base and to the height of this, and we can see a right triangle. We can see also another right triangle here. So we have two right triangles, as we can see, and these right triangles are the same. It has the same value because they have the same hypotenuse. Now we're going to use the slope formula, which is the rise over run. Now first, we're going to get the slope of this right triangle. So here is the f of x. So first the rise, so the f of x of x of r is equals to 0 because it is on the zero line. So we have 0 minus the f of x of, the f of x of l. So we have f of x of l over the run. So we used first the x of r, so x of r, and then minus the x of l is it's equals also to this right triangle. So we have f of x of u. So we have f of x of u, and then minus f of x of r. So we have 0 again over, first we use the the x of u. So we have x of u, and then the x minus x of r. Now we have to simplify this term. So we have we have negative f of x of l over copied x of r minus x of l is equals to f of x of u over xu minus x r. And then we're going to multiply this to this, and then this x of r minus x of l to this f of x of u. So we have negative f of x of l multiplied by x of u minus x of r is equals to, again, f of x of u multiplied by x of r here minus x of l. And then I'm going to distribute this to this term, and then the other side also we have to distribute the f of x of u. So we have f of x of l x of u is since negative times negative is positive, so we have plus f of x of L, x of R is equals to, again, the other term, we have f of x of U, and then x of R minus f of x of U, x of L. After, we have to transpose the all of the x of R on the left side, so we have here f of x of L, xr, and then here we have to transpose, so it became minus f of x of f of x of U, and then x of R, and then this term, since it is negative, so it will become positive, so f of x of L, x of U minus f of x of U, x of L, and then we factor out x of R, since since the x of R is common, so we have f of x of L minus f of x of U, x of R is equals to f of x of L, x of U minus f of x of U, x of L. So we have x of R, we have to remain x of R here, so we have f of x of L, x of U minus f of x of U, x of L over this. So we have f of x of L minus f of x of U. And then, after that, we have to add another term that that those terms will still be equal to 0, so we have to add here x of R is equals to f of x of L, x of U. We have we'll use f of x of U, x of U. So since I used the subtraction operation, we have to use the opposite, so positive f of x of U, x of U, that this term will still be equals to 0, and then copy the last term, which is f of x of U, x of L. Copy the denominator, f of x of L minus f of x of U. And then this, we're going to separate this into two fractions. So we're going to first use these two first terms. So we have x of R is equals to f of x of L, x of U minus f of x of U, x of U over f of x of L minus f of x of U. So again, in the other the other fraction, we have to use this. So we have plus f of x of U, x of U minus f of x of U, x of L over f of x of L minus f of x of U. And then notice that the x of U is common, so we have to factor out x of U in order to. So we have f of x sub L plus f of x sub U. So we have x sub U over f of x sub L minus f of x sub U plus, this is negative. And then notice that on the other side, the f of x of U is common, so we have to factor out f of x of U. So the remaining x of U minus x of L over copied f of x of L minus f of x of U. So we have we can now cancel this one since it has the same so here the x of r, the remaining is x of u plus we have f of x of u multiplied by x of u minus x of l over f of x sub l minus f of x sub u. Now, the it has also other method, or which is x sub u. Here we change this operation into minus because this x sub l will become positive and this x sub u will become negative. So we have x sub f of x sub u multiplied by x sub l minus x sub u over f of x sub l minus f of x sub u. Now, this will be our formula. This will be going to use for the formula of the false position method or the regular falsi method. Now, for the next video, we're going to have an example for this method. So here's the given example. Find the root of the equation x cubed minus 5x squared plus 10x minus 123 by using regular falsi method. Calculate its relative error. Now, here is the formula for the regular falsi method, which we're going to use in finding the root. So, in the first iteration, we will first assume a number that will two numbers that will have a value of a negative and a positive. So first we will use number 9. So f of 9 is equals to 9 cubed minus 5 times 9 squared plus 10 times 9 minus 123. It will give us 291 as calculated. Now, we will assume another number lower than 9, so we will assume number 2. So, 2 cubed minus 5 times 2 squared plus 10 times 2 minus 123 and will give us a negative 115. Now, the answer is are positive and in a negative way. So, the roots lies between number 9 and 2. So, here we'll put the upper 9, which is the upper number. The x of 9, the f of 9 is equals to 291, and the lower, which is the x of l, is 2, and the f of x of l is negative 115. Now, for the first iteration, we will use this formula. So, x of r is equals to upper, which is 9, minus f of x of u, which is 291, times x of l is 2 minus the upper, which is 9, over f of x of l, which is negative 115, minus f of x of u, which is 291. and it will give us 3.983 as calculated. So the first x of r is 3.983. Now, we can't calculate the relative error because there is no other we still don't have other x of r. So we will again substitute the x of r to the given equation. So the f of 3.983 is equals to 3.983 cubed minus 5 times 3.983 squared plus 10 times 3.983 minus 123, and that will give us negative 99.304 as calculated. Now, since the value of f of 3.983 is negative, so uh, so the new x of l will be this 3.983, and the x of u will still be the number 9, and then the x of u will be still the f of x of u will still be the 291, and then the new x of l will be this, since it is still lower than the x of u. So here we put 3.983, and then the f of x of l, the value of f of 3.983 is negative 99.304. Now we will now calculate the second iteration. So x of r is equals to the upper, which is also still 9, minus the f of x of u, still 291, and then x of times x of l, which is 3.983, minus the upper, still 9, over f of x of l, which is negative 99.304, minus f of x of u, which is 291, and that will give us 5.259 as calculated. So we'll put 5.259 here, and then to calculate the relative error for the second iteration, so here ER is equals to absolute value of the new x of r, which is 5.259, minus the previous x of r, which is 3.983, over the new x of r, 5.259, multiplied by 100%, which will give us 24.26% as calculated. So here we'll put 24.26%. Now we're going to again substitute the new x of r to the given function, to the given equation. So f of 5.259 is equals to 5.259 cubed minus 5 times 5.259 squared plus 10 times 5.259 minus 123, and that will give us negative 63.247 as calculated. Now, so since the value of f of 5.259 is negative, so the new x of L will be the 5.259, and the x of U still be 9, since the 5.2 the 5.259 is lower than the upper, which is 9. So we'll put again here the upper still 9, and then the f of x of U will still be 291, and the new x of L will be uh 5.259, and then the value, the f of x of 5.259 is negative 63.247. So now for the third iteration. So here x of U, the upper is still 9 minus the f of x of U, 291, still 291, and then the x of L, which is 5.259 minus the x of U, 9. So the f of x of L will be negative 63.247 minus the f of x of U, which is again 291. This will give us 5.927 as calculated. So here put 5.927. Now, the relative error for the third iteration is equals to absolute value of the new x of r, which is 5.927 minus 5.259 over 5.927 multiplied by 100%, and that will give us 11.270% as calculated. So the roots the roots lies in this. So the final answer for the for this whole for this example is, the final answer is 5.927. And that's all. Thank you.